Welcome to our sixth lesson on quantitative aspects of chemical change. We'll be discussing the empirical and molecular formula today. Now, we said in our previous lesson we will be discussing our different types of reactions. Before we get there, let's just first look at an empirical and molecular formula. Now, there's a difference between our empirical and our molecular formula. First off, our empirical formula is the simplest ratio in which your elements can occur within a molecule, while your molecular formula is then the actual amount in which you would have each of your elements within the compound. Let's, for example, use hydrogen peroxide as our example here. Hydrogen peroxide is H2O2, and that's the actual number of each element within this hydrogen peroxide compound. So that's seen as my molecular formula. But your empirical formula for hydrogen peroxide, that means the simplest ratio in which we would find this molecule would then be a common denominator which we can divide through both of the numbers of each element. Now our common denominator here would be 2. So once we've divided each one of these number of elements by this 2, we're going to end up with 1 hydrogen and 1 oxygen. So that's then seen as the empirical formula, but the molecular formula is in the actual amount of elements in each one of these compounds. Now, when we're going to calculate our empirical formula, there's a few things that we need to take into account. First off, we want to determine the number of moles, and then we will most probably be given percentage values. Now, all that we're going to do with that specific percentage values is we're going to use it as mass values. So all that we'll be doing is we'll take the percentage and then convert it to a mass value that we can measure in grams. Let's go and look at a specific example. Now, the example first starts off by telling us a compound contains 73.9% mercury and 26.1% chlorine. Determine the empirical formula from this. Now, we said we will be given in most cases probably percentage values, which we're just going to convert to mass by converting them just into something measured in grams. So this is then for us going to become 73.9 grams as well as 26.1 grams. So to start off with, we're going to have to follow a few steps. As said, we're first going to convert this for us into grams. So it's going to be 73.9 grams, and that for my chlorine is then 26.1 grams. So this is the masses that I have for mercury and for chlorine. Now we're going to go and calculate the number of moles as said. Now moles is equal to mass over molar mass. But when we are going to determine the molar mass, we are only going to make use of the molar mass of one of these elements. That means I'm going to go and take the mass of 73.9 and divide it by the molar mass for one mercury element, which is 201. And that's going to end up giving me a mole value, unrounded off, of 0.36766 with a few decimal places, but we keep the whole number as is. Now we're going to do the same on the other side for calculating our moles. We're going to have our mass of 26.1 divided by the molar mass for one chlorine atom, which is 35.5, and that will end up giving us a mole value of 0.735 with a few decimal places to it. Now in our next step, we are going to be dividing our numbers of moles by the smallest mole. And that's going to help us to determine the ratio in which the mercury and the chlorine are found to each other. So in this case, if I have to pick between the mercury and the chlorine, our mercury has got the smallest number of moles. So we'll take mercury's number of moles, divided by the smallest number of moles, which in this case is also mercury's numbers of moles, and that ends up giving me a value of 1. If I go and look at my chlorine, I'll take my value for chlorine, which is 0.735 with all its decimal places, divided by the mercury's mole numbers, because that's the smallest mole number according to us, and that ends up giving us a value of 2. Now in these cases, we've rounded the values off basically to the nearest whole number. So that means I'm going to find 1 mercury compared to 2 chlorine atoms every time. And therefore, if this is the case, we'll find that our empirical formula will be Hg and then Cl but there's 2 of them according to our empirical formula. So we're going to place that small letter 2 there as a subscript. So this is how my empirical formula would look like, and that we've determined by first converting the percentages just to grams, taking that mass divided by the molar mass for one of each one of these elements, getting a mole, taking the smallest mole ratio and dividing it by each one of these moles respectively, and then we find out a ratio on which our 2 elements will be found to each other. Now sometimes there could be 3 or 4 or 5 elements that you'll need to be able to determine the empirical formula of. All that you'll do exactly the same stepwise for all of them, and you'll just find the smallest mole value for all of them and divide each one of them by that smallest value to get a ratio in which they will be found next to each other. Now when we get to our molecular formula, we can go and determine that once we have determined the empirical formula. And we will do so further on to go and look at the ratio in which these 2 are found towards each other by taking the molar mass of the molecular formula, which in most cases will be given to you, and then we'll just take our empirical formula, go and calculate its molar mass and divide it then by the molar mass of the molecular formula. From there on we'll get a ratio basically telling us how many times the empirical formula will fit into the molecular formula. Now let's go and look at an example which we can apply to our previous one. So now from here onwards they tell us that the molar mass of the molecular formula is 860 grams per mole. Now from this information we can go and calculate the molecular formula. So let's go back again to our equation. So in order to determine the ratios, we'll take the molar mass of the molecular formula, which was given in this case as 816, and we're going to divide with the molar mass of the empirical formula, which we'll need to go and calculate. Now remember, the empirical formula was given as 1 mercury plus 2 chlorines. So it's 201 plus 2 times 35.5, and this gives us a value of 3. Now this means if we want to go and determine the molecular formula, we'll need to take this empirical formula and multiply every element within it by the value of 3. So originally there was only 1 mercury, so therefore we're going to 3 times this ends up giving us Hg3, and then our chlorine was 2, so 3 times 2 ends up giving us 6. So the molecular formula would thus be Hg3Cl6 for this specific compound. Now the question which I would like you to go and attempt is where we have a compound that contains 57.5% sodium, 40% oxygen, and 2.5% hydrogen. Determine the empirical formula from this. Remember to go and look at your steps again as to how you would convert all of these percentages to a mole value from which you can then determine the ratio which these elements are found. Now first pause your play and attempt the question before you're going to be looking at the answer.